Okay, so we are going to start with which chapter? Polymers. So we look at heading polymers. So right, what is the name of the chapter? The name of the chapter is polymer. Now, while we start with polymers, let me give you certain example. So more ঘৰত তুমি plastic bottle use কৰা নে? So কৰা? Yes or no? দেখিছা plastic bottles? Polythene use কৰা নে? Polythene use কৰা নে নকৰা? Yes or no? Yes? You use polythene? Yes. Then synthetic clothes কিছুমান পিন্ধা, কেতিয়াবা stylish frocks, dress you all wear, they are made up of synthetic polymers. Cup, plate, all these melamine cups and plates, then buckets, toys, all these are made up of what? All these are made up of what? Is it very hard? It is very soft. What do you think? What do you all think? Lakshmi, what do you think? The day-to-day use things, pen. Yes, these are all day-to-day use things. What are these? These are actually compounds made up of carbon and hydrogen, which are modified and reacted under different conditions to give you certain useful products of your day-to-day life, which are known as polymers. Polymers are actually macromolecules. Why macromolecules? Because they are big in size, in mass, they are big in size. Why macromolecules? One more point is that they are formed by joining. We are going to join by joining of repeating same unit, repeating structural unit, by joining repeating structural units, by repeating structural units. So they are formed by joining repeating structural units on a large scale, not in small quantity, but on a large scale. Next, when I say polymers, that means this is also a macromolecule which is made from combination of different monomers, which are made from combination of different monomers combined together to give you a polymer. Different monomers combined together to give you what? Polymers. So when I say polymerization or polymers, it indicates that it is going to form a macromolecule from monomers which are going to link with each other, by covalent bond. Okay, and the entire process, the process of formation of polymers formation of polymers from respective monomers is called polymerization. So the process of formation of polymer from respective monomer is called what? Polymerization. If you repeatedly add a monomer of the same type, it gives a polymer, and the process is known as what? Polymerization. So let us see one example. The most easiest example I'm going to do right now is, if I take ethene molecules n times, means numerous times, how many times you want to take, it is up to you, and I polymerize, that means I join these units again and again, I get a compound which is known as what? Polythene, which is known as what? Polythene. Polythene will be gone, but the actual name is what? Polyethene, which means it is repeatedly joined, ethene molecules is repeatedly joined to give polythene. Okay, গম পাইছা polythene to কেনেকে বনায়? Ethene is joined, linked with each other repeatedly by covalent bond, and you get polythene. Okay, this is one of the example of polymerization. May I erase the board? Wrap করে দিও? Wrap করে দিও?
Yes, ma'am.
Okay, fine. Now, one more example, let us see one more example. So if we see more example, our idea will be clear. Now I take one chemical compound whose name is hexamethylene diamine, and I add this hexamethylene diamine with another compound which is known as adipic acid. One is hexamethylene diamine, and it is adipic acid. Then it polymerizes to form. Just see what does it forms. So what it forms, we are getting nylon 66, and nylon 66 is a polymer. Nylon 6 is what? It is a polymer. Now how we got it? We are going to do this particular reaction later in the chapter. Just remember that we are getting a polymer which is known as nylon 66. Have you seen nylon cloth? I think everybody have seen nylon cloth. Nylon cloth to assume genji kapur dekhisa? Yes. Have you seen the nylon cloth? I think everybody have noticed the nylon cloth. Yes, it can be stretched. Okay, I am pretty sure that everybody have noticed that nylon cloth to kenuka. So it is a polymer. Now let us go towards the classification of polymers. Now what we have to remember in the chapter, we have to remember certain important definition with example. So what is the first definition I have learned? I have learned what is polymerization. Now we are going to learn about the different types of polymers. So let us see first the classification. What are the different classification groups of polymers, and then classify them. Shall we start? Class 8 and CBSE pa kunba ahisa niki? CBSE background pa kunba ahisa niki?
Ma'am,
Class Assam High Secondary Education Council ase niki polymers or kotha? Class 8
ma'am, nasile.
The CBSE background thakile pala hen class 8 etu chapter ase. Classification based on source. That means we are going to see the polymer from where they have their monomers, or from where they are getting the raw material. So if I take natural polymer, from the nature, you are going to get this polymer. That is why it is known as natural polymer. So what are the examples of natural polymer? This most common example is protein. The most common example is protein. Protein is a natural polymer of amino acids. Amino acids combines to give protein. Next, in plants, you get cellulose. This is a natural polymer. Starch is a natural polymer. Rubber, natural rubber is a natural polymer. Okay, this is one classification. Next classification is semi-synthetic polymer. That means naturally and artificially both these polymers are prepared. So let us see. Example, you can say cellulose derivatives, means it is having natural polymer along with the artificial chemicals to make this polymer. So example, cellulose derivative, which is cellulose acetate, which is also known as rayon, and cellulose nitrite. Cellulose nitrite. Nitrate. Third is fully synthetic. That means artificially this polymer are based is formed. So artificial polymers, now only we have written one polymer named nylon 6. It is artificially prepared. Artificially prepared. We have more examples like Buna S. All these polymers, how they are formed, we are going to discuss in the later part of the chapter. Now, what is the classification? First classification from the source. If it is obtained from the nature, then natural polymer. If it is obtained from nature and synthesized, then semi-synthetic polymer. And if it is artificially prepared, then it is a synthetic polymer. Okay. Shall we go to the next part?
Yes, ma'am.
Okay, thank you. Okay, now number two classification is classification based on structure of polymer. Okay, so some of these polymers we are going to classify on the basis of the structure. Since these are molecules, so they will have certain structure. Let us see what is the classification. The first classification is linear polymer. Now, what is linear polymer? Linear polymer, you will find that the polymer will have straight chain. Okay, the polymer will be formed by straight chains. Straight chain. Okay, it is formed by straight chain. Example, you will say straight chain structure. Actually, this we are going to see the structure of the polymer here. And on that basis, if you see, it is having a straight chain. That is why it is referred as linear polymer. And it is not a short chain. It has to be a long straight chain. Then only it is going to be a linear polymer. Example, what we get? We get high density polyethylene. In short, we write HDPE, high density polyethylene. And PVC, polyvinyl chloride. PVC pipe, have you seen PVC pipe? Pipe bilak dekhisa, ekdom dikhol dikhol pani je uthai pipe bilak dekhisa, blue color PVC likhi thua thake. Dekhisa tomaloke sobe? Yes? Okay. Next category is branched chain polymer. Branched chain polymer. Okay, the linear polymer is a bit modified and it has certain branches in between. That is why it is referred as branch chain polymer. That is why it is referred as a branched chain polymer. So you'll find that at certain position, the branching is there. So it is known as branched chain polymer. So example, what you will find in this, you will find low density polyethylene, low density polyethylene. So this is about branched chain polymer. Third category is cross-linked, or network polymer. Cross-linked or network polymer. So what is happening here? Actually, these polymers are formed when there are certain functional groups present in the monomer. It may have 2 functional group, it may have 3 functional group monomer, and they combine together with 2 special criteria. One is what they are cross-linked, and also they are linearly joined. So there is a difference. You'll find that they are linked like this, in this way. So this type of polymers are known as cross-linked, but this happens only when there is a bifunctional or trifunctional monomers which have strong covalent bond. Example, you will find bakelite. Example, you will find bakelite, melamine. When I say all these words, don't get scared, because these words will be later explained to you why they are getting this kind of name. Okay, so what is the classification we got right now? Classification is based on the structure of the polymer. Linear polymer, you will get long straight chain polymer. Example, high density polyethylene, polyvinyl chloride, etc. Then branch chain polymer, which you are going to get is the low density polyethylene. Cross-linked or network polymer is bakelite, melamine. Okay, so this is all about classification based on structure of polymer. Now let us go to the next part. Now the next part is very interesting. Okay, next classification is very interesting. So can I erase the board? Can I erase the board?
Yes, ma'am.
Yes. Okay, Nishita. Thank you. Now classification based on mode of polymerization. How they are polymerized, on that basis we are going to classify. So first classification is addition polymer. Addition polymer. Now in this category, whatever definition will be discussed is very important, as questions related to this topic is very common. So let us write what is addition polymer. So how is the addition polymer formed? They are formed, how they are formed? They are formed by repeated addition, of repeated addition of monomer molecules, by repeated addition of monomer molecules possessing. So there is a condition. What is the condition? Possessing double or triple bonds. Double or triple bonds. Yes, they are formed by possessing from monomer molecules possessing double or triple bonds. Okay, so example, let us write one example. One example, let us write. We have done this example. What is this example indicating? We have n number of ethene molecules which are polymerized, repeated units joined together, and you get what? Polyethylene. Yes or no? Yes or no? We get polyethylene, yes or no? Why not?
Yes, ma'am.
Yes. Now, here there is an interesting fact which we are going to discuss under this category. You will find that since they are formed by repeated addition of monomer, we have two categories of addition polymer. One is homopolymer, and the other is copolymer. Okay, one is known as what polymer? Homopolymer, and the other is known as copolymer. Homopolymer, what will happen in homopolymer? Homogeneous mixture. When I say homogeneous mixture, what do you mean? Homo mane ki hoy? Uniform hoy, same hoy. Yes, uniform hoy, same hoy. Hoy na hoy?
Yes, ma'am.
Hoy. Yadu ki hoy homopolymer. Juntu monomer unit lum, whatever monomer unit I will take, it will have a single monomeric species. Only the same species will be repeated. Simple monomeric species will be. This means polyethylene, ethene, n times many. Same single monomeric species, single monomeric species is repeated. Okay, that means same monomer is repeated. In simple words, same monomer is repeated. Copolymer. Now, what happens in copolymer? It is again addition polymer, but there is a difference. What happens? There can be two different monomers. Two different monomers. Okay, there can be two different monomers which add to form monomers which add to form polymer. Okay, so here you have to know the difference, homopolymer and copolymer. So whenever you will be asked about the difference between homopolymer and copolymer, you should remember that homopolymer is formed by same monomeric units, or you can say addition of same monomeric units to form polymer. And for copolymer, you can say the addition of two different monomers. Okay, now this is under which category? Addition polymer. Let us see the example for this. Let us see this example. So what we are going to take? We are going to take two different monomers. So what is my example? My example is 1, 2, 3, 4. 4 means but, and at 2 position there are double bond. So the name of this compound is buta 1,2-diene. I'm not going to repeat the nomenclature. 1,2 to 1,3, sorry. 1,3-diene. 2 to the position of 9, 1,3 position. 1,3-diene. Or you can say 1,3-butadiene. That is also correct. So buta 1,3-diene. This is one monomer. And the next monomer, what I am going to take is C6H5CH2 double bond CH2, which is known as styrene. It is an organic compound. Here also we have double bond. Here is also a double bond, and it is fulfilling the condition that repeated addition of molecules possessing double bond or triple bond. So it is possessing double bond. Now, when I will add these two, I will get a product which is known as Buna S. Now, how will I get? See, this becomes single, this double, single, double, then single. So, এইটো লিখিবলৈ অকমান দিগদাৰ হৈছে, মোক ৰাব কৰি দিও নে স্ক্ৰীনখন? প্ৰডাক্টটো অকন ওপৰলৈ লিখি দিও, হ'বনে? এই বস্তুটো প্ৰডাক্টটো ওপৰত লিখি দিছো হা।
Okay.
Okay, just check. Here I am writing the product. Space to kumi gol mane. CH2 CH double bond CH CH to double bond. Etia eta single bond etu logot lagi jabo. Next compound to logot lagi jabo. CH2 CH single C6H5. Okay, this compound is known as what? Buna S. This compound is known as what? Buna S. A compound to kill the Buna S. So butadiene and styrene, they add together to give you a polymer which is known as Buna S. The example here is Buna S. What type of polymer it is? It is a synthetic polymer. Synthetic polymer example আমি Buna S কথা লিখিছিলো। হয় না মনত আছে নে? এতিয়া লিখি আহিছিলো। লিখা হল সবৰে?
Hi, ma'am.
Okay, now let us go to the next category. Classification based on molecular forces. Classification based on molecular forces. It black লাগিছে নে green লাগিছে বাৰু screenত? Okay, so we are going to class black লাগিছে no. We are going to classify this and terms of force. The force to kenuka force thakibo pare. Intermolecular force, the only thing which is present between the atoms is intermolecular force, which are classified as ionic bond, covalent bond. Apart from those two forces, we might have van der Waals forces, hydrogen bonds. All these mechanical forces properties will be there between the atoms while they form polymers. So let us see what kind of molecular forces are there in the different categories of polymers. The first category is elastomers. So when I say elastomer, what do you understand? Elastomer, the word itself gives us an idea that it is elastic. Elastic property is same. It's rubber-like solid and is elastic. Okay, and if it is having elastic properties, is it having strong bonds? Do you think it is having very strong bonds? Jodi elastic property ase, both strong bond ase niki? Tumar ki bhaba? Is it having elastic properties? When I say about elastic property, what do you think? Is it having strong interaction or weak interaction? Yes. Question কি হ'ব পাৰে?
Weak হ'ব নেকি?
Weak হ'ব কাৰণ তুমি elastic এটা টানিব পাৰিবা না, strong হলে elastic টো যদি strong হয় তুমি টানিব পাৰিবা নেকি? নোৱাৰা। So it is having elastic properties. So elastomers, you can say they are rubber-like solids. They are rubber-like solids with elastic properties. Then held together by what force? Weak force. Held together by weakest intermolecular forces. Weakest intermolecular forces. Okay, then they can be stressed. And what are the examples for elastomers? Let us say examples. It is Buna S, then Buna N, and neoprene. These are examples of elastomers. Okay, then they are having cross-linked structures. So these are the minimum points which you need to know. Okay, next category is fibers. So have you seen fibers around your home? Fibers দেখি পাইছে না? Fiber বস্তু দেখি পাইছে না নাই পা? দেখিছা না fibers? নাভাঙে সোনকালে ফাইবাৰ প্লাষ্টিক ফাইবাৰ বটলবিলাক থাকে যে okay so fibers are what they are thread forming solids they are thread forming solids do they have strong force yes they have high tensile strength and high modulus okay strong intermolecular forces like hydrogen bonding is there strong forces you write hydrogen bonding next they impart colors they impart crystalline they have you can directly write examples are impart crystalline nature these are the points which you have to remember regarding fibers example of fibers you can write polythene polystyrene STYRENE and polyvinyls polyvinyl polyvinyl কাপোৰ দেখিছানে polyvinyl mats দেখিছানে ঘৰত এইবিলাকটো দেখা বস্তু নেদেখা বস্তু নহয় ঘৰত দেখা বস্তু এইবিলাক ছবি দেখি পাইছা এইবিলাক বস্তু
Ma'am, ma'am, last word to ki likhise?
polyvinyl
Ma'am, because different polyamides and polyester ase fiber example.
লিখিব পাৰা sorry মই amides হেৰি লিখিলো sorry এইটো থাৰ্মোপ্লাষ্টিকৰ লিখিলো দেই polyamide sorry ha polyamides polyesters এইটো কেটে next next category le ahiso এই দুটা difference কোকতে ha third category is thermoplastic আৰু thermo setting ঠিক আছে thermoplastic plastic বুলি যেতিয়া কৈছো না এটো কি হিট কৰি কুল কৰি দিলে হার্ড হৈ যায় ঠিক আছে what happens to this kind of plastic when you heat it it becomes soft on heating and hard on cooling. Hard on cooling, যেটা ঠান্ডা করে দিম যেটা হার্ড হয়ে যায়। এইটো থার্মোস্ট্যাটিঙত কি হ'ব? থার্মোস্ট্যাটিঙত কি হ'ব? এবাৰ যেতিয়া পলিমাৰটো ফৰ্ম হয়, you cannot break it again. Hit কৰি দিলে সফট নহয়, এবাৰ ফৰ্ম হৈ গ'ল সেটেল হৈ গ'ল। It cannot be broken again and formed. Once formed is done. So these are already heavily branched molecules which on heating undergo extensive cross-linking. Okay. Example yet swa. Yet ago example kinakolikisu. Polythene, polystyrene, styrene, polyvinyls. Yet examples are bakelite, urea